The solution to a quadratic is the value of x or values that make the equation true. There's a few ways to find the solution. 1. We can factor the quadratic. 2. We can complete the square. Or 3. We can use the quadratic formula. Here, we're going to go over the quadratic formula and how to use it. Assuming that the quadratic is in the form ax squared plus bx plus c equals 0, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. As you can see, there's a plus or minus here that implies that there might be two solutions. And here we have b squared minus 4ac under the square root, and b squared minus 4c is known as the discriminant. To remember the quadratic formula, people often sing this quadratic formula in the tune of Pop Goes the Weasel. And the lyrics are down below. Like we talked about previously, the discriminant is b squared minus 4ac. And remember, in the formula, it's under a square root. So the discriminant is important because it tells you about the nature of the solutions. If b squared minus 4ac is greater than 0, then you have two real roots. The graph might look something like this. We have a root here and a root here. If you have b squared minus 4ac equals 0, then you get one real root or a double root. Something like this, where it hits the axis one time. If you have b squared minus 4ac is less than 0, you have 0 real roots or two imaginary roots. As you can see, it doesn't hit the axis at all. And this is because it's a square root. So if you do a square root of something like maybe negative 5, you end up getting square root of 5, I. And this is what makes it an imaginary root. Now, let's practice finding the discriminant and the nature of the roots. So first, discriminant is going to look like b squared minus 4ac when the equation is in the form ax squared plus bx plus c equals 0. So let's get started with our first one. 3x squared minus 7x minus 5 equals 0, or in this form so we can get started. b squared minus 4ac is equal to negative 7 squared minus 4 times 3 times negative 5. This gives us 49 plus 4 times 3 is 12. 12 times negative 5 is negative 60. As you can see, there's a negative here, so that becomes a positive 60. So we know this is 109. And 109 is greater than 0, which means this gives us two real roots. What about this one? We have 2x squared plus x plus 6 equals 3. First, let's check if it's in the proper form. It's not. We need this side to be equal to 0. We're going to subtract 3 from both sides to give us 2x squared plus x plus 3 equals 0. Now we're ready to do b squared minus 4ac, which is equal to 1 squared minus 4 times 2 times 3, which is equal to 1 minus 4 times 2 is 8. 8 times 3 is 4. Gives us 1 minus 24, which gives us negative 23. Because negative 23 is less than 0, we know it's two imaginary roots. Or we can write this as 0 real roots. Now, let's practice using the quadratic formula to find solutions. Let's start by writing the quadratic formula down. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're looking for something like ax squared plus bx plus c equals 0. You can see it's already in this form. so we can directly plug in our numbers. So x equals -1 plus or minus the square root of 1 squared minus 4 times 1 times -42 over 2 times 1. This gives us -1 plus or minus square root of 1 plus 4 times 42, which is 168. Divided, this gives us -1 plus or minus the square root of 169 divided by 2. Now we can simplify this more because 13 squared is 169. We can do -1 plus or minus 13 divided by 2. So we know we have our two solutions. One of them is x equals -1 plus 13 divided by 2. And the other one is x equals -1 minus 13 divided by 2. This gives us x equals 12 divided by 2, which is 6. And this one gives us x equals -14 divided by 2, which is -7. Our two solutions are -7 and 6. Here we have x squared plus 8x plus 17 equals 0. Let's start by writing down our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You can see this is an ax squared plus bx plus c equals 0 form, so we can get started. X equals -8 plus or minus square root of 8 squared minus 4 times 1 times 17 over 2 times 1. Now, simplify. We get -8 plus or minus the square root of 64. We have minus 4 times 17, which is 68, over 2. This gives us -8 plus or minus the square root of -4 divided by 2, which can be simplified as -8 plus or minus square root of 4. And we take out the I because I is square root of -1 divided by 2. And then square root of 4 is actually 2, so we can get -8 plus or minus 2i divided by 2. As you can see, we can divide everything by 2, which gives us -4 plus or minus I. We know that one of our x's is -4 plus I, and the other one is x equals -4 minus I. And as you can see, these two are imaginary solutions, which makes sense because our discriminant here was negative. Here we have 9x squared minus 12x plus 4 equals 0. Let's start by writing our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So this is already in ax squared plus bx plus c equals 0 form. So let's get started. X equals -b plus or minus square root of b squared, which is -12 squared, minus 4 times 9 times 4 over 2 times 9, which is equal to 12 plus or minus -12 squared is 144 minus 4 times 9, which is 36, times 4, which is 144. Gives us 2 times 9, which is 12 plus or minus 144 minus 144, which is the square root of 0, which is 0, divided by 18. This gives us our solution as 12 divided by 18, which can be simplified to 2/3. So, as you can see, our discriminant was 0, which means we have a double root. So both our solutions are going to be 2/3. Another shortcut we could have taken is if we saw this and we recognized it as a perfect square trinomial. So 9x squared minus 12x plus 4 can be factored to 3x minus 2 squared equals 0. Knowing this, we know that 3x minus 2 equal to 0, so x is equal to 2/3. A lot of the times, for quadratics, there's many different ways to solve it, but in this case, I want to show you the quadratic formula. Here we have 2x squared minus x minus 3 equals 0. Let's start with our quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac over 2a. As you can see, it's already in ax squared plus bx plus c equals 0 form, so we can get started. Equals negative b, 1, plus or minus square root of negative 1 squared minus 4 times 2 times negative 3 divided by 2 times 2 gives us 1 plus or minus the square root of 1 plus 4 times 2, which is 8, times 3, which is 24, divided by 4, which is equal to 1 plus or minus the square root of 25 divided by 4, which is 1 plus or minus 5 divided by 4. So we know that x equals 1 plus 5 divided by 4, and x also equals 1 minus 5 divided by 4. X is equal to 6 divided by 4, which is 3 over 2. And x is equal to negative 4 divided by 4, which is negative 1. So you know our two solutions are negative 1 and 3 over 2. We've reached our final challenge question. Here we're given 3x squared plus 5x minus 11 equals negative 7, and we want to find the discriminant, find the nature of the solutions, and then find the solutions themselves. So first, let's start. We have 3x squared plus 5x minus 11 equals negative 7. That's not in the proper ax squared plus bx plus c equals 0 form. So let's change it. So this should be 3x squared plus 5x plus 7 on both sides gives us negative 4. Now we have something we can work with. Let's start by finding the discriminant, which is b squared minus 4ac. This gives us 5 squared minus 4 times 3 times negative 4. This gives us 25 plus 4 times 3, which is 12, times 4, which is 48. This gives us 73. Because 73 is greater than 0, we know that we have two real solutions. Now we can use the quadratic formula to find our solutions. We have x equals negative b plus or minus the square root of b squared minus 4c over 2a. Let's find it. X equals negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 4 over 2 times 3. This gives us negative 5 plus or minus the square root of b squared minus 4c, which we already found to be 73. This is going to be 73 divided by 6. So we know our two solutions are x equals negative 5 plus the square root of 73 divided by 6, and x equals negative 5 minus the square root of 73 divided by 6. And that's the end of this video. Thank you so much for watching.